Okay, so I'm now recording. Okay, so last class 3.4, we went over theorem 3.4.1. Let L be the line in R2 or R3 that connects the point x naught, that contains the point x naught and is parallel to the non-zero vector v. Then the equation of the line through x naught that is parallel to v is x equals x plus t v. If x naught equals 0, then the line passes the origin and its equation has the form x equals tv. So this is an equation to express a line that goes through a point and is parallel to a fixed vector. Okay. Theorem 3.4.2, let W be the plane in 3 space that contains the point x naught and is parallel to the non-collinear vectors v1 and v2. Then an equation of the plane through x naught that's parallel to v1 v2 is given by x equals x naught plus t1 v1 plus t2 v2. And if x naught equals 0, the plane passes to the origin and the equation has the form x equals t1 v1 plus t2 v2. So an illustration of that I gave last class. And so let me just remind you, if you have your 3 axes, because you're living in 3 space. So let's say you're in 3 space and you want to talk about the plane that contains the point x naught and is parallel to 2 non-collinear vectors, v1 and v2. Then you can think of that's the point x naught. You can draw the vectors v1, v2, which are non-collinear, meaning they can't be put in any particular line. And so you have this point x naught, right? It's a vector going from the origin to this point x naught. That's one way to describe it. And you want to talk about the plane through that point x naught and parallel to those 2 vectors. It's just a plane that looks like this. Okay, like this green thing I just drew. This green thing is the plane. Okay, it contains the point x naught. The point x naught is in that green thing, and the 2 vectors lie on the plane. Okay, and so this plane is expressed by the equation x equals x naught plus t v1, t1 v1 plus t2 v2. Okay, so this is a way to express a plane as contain the point x naught and parallel to 2 non-collinear vectors v1 and v2. Okay, so that was some of that at the end of last class. And we defined, so this equation defines a line through x naught that's parallel to v in, it's parallel to v, okay? And so in 3 space, you have this equation, right? And so you can write it like that. Okay, so the equations 5 and 6 are the vector forms of a line and plane in n space. Sorry, so this is a line in n space, and this is a plane in n space. The vectors of these equations are expressed in terms of their components, and the corresponding components on either side are equated. The resulting equations are called parametric equations. So if you think of this equation, instead of writing them as vectors x, x naught, and v1 and v2, instead you broke down these vectors by their components, and you had equations that saying the components of this side equal the components of that side. For each component that are the same, you had a separate equation. That list of equations would be parametric equations, whose solutions would be all the points on the line or plane expressed by the original vector equation. Okay, so I'm going to start here with, so we start with some examples. Okay, so A, find a vector equation and parametric equations of the line in 2 space that passes through the origin and is parallel to the vector v equals -2, 3. Okay, so solution. So we want a vector equation and parametric equations of the line in 2 space that passes through the origin and is parallel to the vector v equals -2, 3. So if you were to illustrate this situation, you would have, you're in 2 space, so you have the x-axis and you have the y-axis, and you have a vector v, which is equal to the vector -2, 3. So you can think of the point -2, 3, and you can think of the vector going from the origin to that point. That vector is describing the vector -2, 3. So the coordinates here are -2. This is -2. This is -3. Oh, -2, 3. Okay, so we're up here. -2, 3 is there. And so then we have, okay, so now you have that vector there. So that's the vector -2, 3. So you want the line through the origin. You want the line that passes through the origin and it's parallel to that vector. So parallel means it goes in the same direction. So it's just going to go through the origin and through that vector. So it's not perfectly straight there. It's a line going through the origin and in the same direction, being parallel to that vector. And so we want the equation representing that. So x is representing points on that blue line. And so the representation is x naught plus tb according to our equations. But x naught is 0 because we are starting at the origin. We don't have a vector x naught where we then think of the line through x naught, right? We don't have that situation. We're starting at the origin. And so our x naught vector is the 0 vector. We're starting at the origin, okay? So x naught is 0. And then we add to that tv, where v is the direction of this, is a vector with the same, that lies on this line. So that's -2, 3. Okay, so the vector is -2, 3. And so when you multiply this by t, you get -2t, 3t. And so what that means is that your points on the line represented by x are equal to -2t, 3t. So the parametric equations are x is equal to -2t, y is equal to 3t. Okay, and this might cause some confusion because you're seeing x here and you're seeing an x here. So mathematicians like to reuse notation. So this x here is the first coordinate of a vector x there. Okay, this vector x is really a point. On the line. And so when I say x in one case, I mean a point in the line, which is x comma y, where the other x is the first coordinate of a point on the line. So in one perspective, you think of x as a point in the line, and the other perspective, you think of x as the first coordinate of that point, x on the line. Okay, so this x means the first coordinate of a point x on the line. And so these are parametric equations for the coordinates of a point on the line. Okay, so these are parametric equations, okay, for points on the line. Okay, and if you wanted the vector equation, then the vector equation would just be x comma y is equal to t times -2, 3. And so this would be the vector equation. Okay, so the vector equation is also describing the line. But if this vector equation is describing the line using vectors. Okay, so x comma y is a vector, right? -2, 3 is a vector. X comma y is a vector. Those two are vectors. And so this equation is built from vectors. The other equation, x equals -2t and y equals 3t, you're using parametric equations to describe the line. So that's why I have names: vector equation and parametric equation. Okay, so the answer is on the whiteboard. Okay, so we then described the line using a vector equation, also using parametric equations. For B, find a vector equation and parametric equations of the line in 3 space that passes through the point P naught, which is 1, 2, -3, and is parallel to the vector v equals 4, -5, 1. Okay, so we'll have to continue this next class. This is all I had time to cover. So class ends at 9:50. So I'm going to stop now. Okay, so we're going to continue next class. I will say the homework for next class. The homework for next class is the last homework we did was 3.2. So for next class, I want you to do 3.3 and 3.4 next class. Okay, we're currently on. We're currently on 3.4 now. So 3.3 for next class. Okay. So homework for next class is 3.3. I didn't assign last class because you had the test today. Okay, so 3.3 for next class. The meeting will be at 10:30, and I will send the invite to your email address associated with Blackboard. Send the exams by 10:30 p.m. by email to the email I told you. If you can't make the meeting at 10:30, if you absolutely can't, okay, if you can't, then you can stay here now, and I will confirm to you that I received your exam now, okay? But if you can make the meeting at 10:30, then I want to see you at 10:30. This is only if there's an emergency, if somebody can't make it at 10:30, okay? So have a good night, and hopefully I see all of you at 10:30 in the other meeting, okay? Hope you all did well. See you maybe soon, okay?